Finishing up 6.2 day 2, we have to work out the other case where r was equal to 0. So once again, we're going to be generating our terms. Why am I choosing k equals 0? Well, I'm going to look at my smaller subscript. I'd like to make that become a 0, choosing the appropriate value of k. So I will get c sub 1 equals c sub 0. Down below, of course, we'll just be left with 1 times 1, which is just a 1. We could let k equal 1 and get c sub 2 would be c1 all over. Well, 3 times 1 is 3, plus 1 is 4. 1 plus 1 is a 2. 4 times 2 is an 8. But of course, c sub 1 is really equal to c sub 0. We could let k equal 2, we'd get c sub 3. And that would mean that we'd have up here a c sub 2 all over. Well, 2 times 3 is 6. 6 plus 1 is a 7. And 2 plus 1 is 3. So 7 times 3 is 21. So we get c sub 2 all over 21. But don't forget, c sub 2 is really c sub 0 all over an 8. And when we bring the 8 down, 8 times 21 will get you 168. So as we're looking at this, just as I had mentioned before, this might be a nice time to bring back the fact that we're assuming that we'll have x to the r out in front, and then of course we'll always have a expansion. We'll have our c sub 0, c sub 1 to the x to the 1, c sub 2, x to the 2, c sub 3, x to the third, and so forth. And I think you can see that all of these constants would be c sub 0. This first answer that we're getting, you could say it's x to the 0, which is going to wipe out. But we'd have c sub 0. C sub 1 was also equal to c sub 0. C sub 2 is equal to c sub 0 all over an 8. C sub 3 was, and don't forget we've got our x squared here. Here's a c sub 0 over 168. And as we continue on, please understand that x to the first is just a 1. And tell you what, all of these c sub 0s, I guess what we've got to be very, very, very careful about is that's not the same thing as what we had in our previous case. So maybe let's just call c sub 0 something else. In class we called it c sub a. You could just call it c sub 1 if you'd like, and you could even factor it out if you'd like. That there's nothing wrong with that whatsoever. So what you'll see very quickly right now is you do wind up with these singular problems, with these two different answers. Your most general form, you could see here we had a C1. We could call that C1, Y1. Even over here, if we'd let C sub 0 equals C2, everywhere where we have a c sub 0 in that previous case, we could have that written out just as well. We could factor out a second one. We could have called it c sub 0 just as well. And that would be a great way to work that all out. So that's it